Have you ever touched something hot and yanked your hand back before you even really registered the burn? What is going on in that split second? Well, today we're going to trace that exact journey. We're going to follow a pain signal from the tip of your finger all the way up to your brain and see what happens next.
So here's our whiteboard map for this whole process. We're going to start with what pain even is, walk through the 4 major phases of the pain pathway, and then we'll tie it all together with the clinical picture. By the end, you'll have a solid, exam-ready grasp of how this all works.
All right, first things first, let's set the stage. To really understand how pain works, and more importantly, how we can actually manage it, we have to get the basic concepts down. We need to separate the physical signal from the feeling itself.
And the first big word you got to know is nociception. Just think of this as the raw data. It's the nervous system's way of saying, hey, something potentially damaging is happening here. It's the objective physical event before your brain even gets a chance to label it as that feeling we call pain.
And then there's this quote which is just foundational in healthcare. It gets to the heart of the other side of the coin. While nociception is the physiologic process, pain is the subjective experience. It's personal. This reminds us that if a person says they're in pain, they are, period. So nociception is the signal, but pain is the perception.
So how does that signal actually travel? Well, it uses 2 main types of neurofibers. Think of the A-delta fibers as the express lane on a highway. They're myelinated, which is basically a fatty coating that acts like insulation on a wire, letting that electrical signal travel super fast. This is your fast pain, that initial sharp ouch that makes you pull your hand back. Then you've got the C fibers. These are kind of like the slow local roads. They're unmyelinated, so the signal moves slower. They carry that slow pain, the dull, throbbing, or burning ache that sets in afterward.
Okay, let's dive into our first official phase, transduction. This is the spark. It's that magic moment where a physical event in the world gets converted, or transduced, into the language of the nervous system, an electrical signal.
And it all starts right here, at the nerve endings in your tissues. It could be heat from a flame, pressure from a sharp object, or even chemicals released by damaged cells. Whatever it is, these stimuli wake up specialized pain receptors called nociceptors. You've got them all over your body.
So this is it. This is the moment of transduction. That physical stimulus literally forces open tiny ion channels on the nerve ending, and that creates an electrical impulse, an action potential. And just like that, the physical event is now a neurological one, ready to start its journey to the brain.
Okay, so our electrical signal has been created. Now it's got to get to headquarters, the brain. This brings us to phase 2, transmission. This is the trip up the pain highway.
And remember our 2 types of nerve fibers, the A-delta and C fibers? Well, these are our first-order neurons. They act as the on-ramp, carrying that signal from the site of injury straight into a specific processing area in the spinal cord known as the dorsal horn.
Let's zoom in on the spinal cord itself. You can see right here where those first-order neurons come in and connect to the dorsal horn. Think of this area as a busy intersection or a gate where the signal gets processed and handed off.
Now, this next step is absolutely critical and a huge point for exams. The first-order neuron passes the message to a second-order neuron. And what does that neuron do? It immediately crosses over to the opposite side of the spinal cord before it starts heading up to the brain. This is why an injury on the right side of your body is actually processed by the left side of your brain and vice versa.
So that second-order neuron zips all the way up to the thalamus, which is kind of like the brain's central relay station or main post office. In the thalamus, it hands off the signal one last time to a third-order neuron, and that neuron carries the message to its final destination, mainly the somatosensory cortex, which is the part of your brain that figures out where the pain is and how much it hurts.
So, the signal has arrived, the message has been delivered, but now the brain has to actually figure out what it all means. This brings us to phase 3, perception. This is where we become consciously aware of the pain.
Now, perception isn't just like a light switch flipping on. It's a really complex interpretation. It involves not just the sensory part of the brain, but also the limbic system, your emotional center. This is what makes pain more than just a sensation. It's what makes it a rich and often unpleasant emotional experience.
We can actually break perception down into 3 interacting systems. The sensory system is like the reporter. It just gives you the facts. This is a sharp pain on my thumb, and it's an 8 out of 10. The affective system adds the emotion. Wow, I hate this feeling, and I want it to stop. And finally, the cognitive system puts it all into context based on your past experiences. Okay, I've been burned before. I know this will hurt for a bit, but it will heal. All three work together to create your unique experience of that pain.
So you might think, okay, the brain gets a signal, we feel the pain, story's over. But not so fast. The nervous system isn't just a passive receiver. It can actually control the signals it's getting. And that brings us to our final phase, modulation, which is basically the body's own volume control for pain.
Your nervous system has this amazing ability to either amplify pain signals or suppress them using different chemicals. On one side, you have the facilitators, things like substance P and glutamate, that crank the volume up. On the other side, you've got the inhibitors, like serotonin, and your body's own natural opioids that turn the volume way down.
And this is how it does it. It's incredible. The brain doesn't just receive signals, it sends them back down. It's called the descending pathway. Your brain can literally send an order down to the spinal cord, telling it to release its own painkillers, endogenous opioids, like endorphins. These molecules then act like bouncers at a club, blocking the incoming pain signal from ever getting up to the brain in the first place. It's your body's own powerful, built-in pain relief system.
So, now that we've traced the entire path, from the initial spark all the way to the brain's response, let's see how this all connects to the clinical picture. Understanding this whole pathway is the key to understanding the different kinds of pain we see in our patients. And this table is a classic exam topic. Acute pain is the system working exactly as it's supposed to. It's a protective alarm that tells us something is wrong. But chronic pain, which lasts longer than 3 months, is the system malfunctioning. It's like the fire alarm is still blaring, even though the fire was put out weeks ago. It stops being protective and becomes the problem itself. And sometimes, the pain highway itself, the nerves, get damaged. This is what we call neuropathic pain. It's not caused by an outside injury, but by a problem within the nervous system. The wiring gets all crossed up, leading to bizarre sensations like burning, tingling, or shooting pains, often with no obvious cause. So we've traced the signal from the initial spark through transmission to perception and finally to the body's own ability to modulate it. We've seen that it's not a simple one-way street, but this dynamic, incredible system with its own volume knob. Which leaves us with this final thought. If the pain system really does have its own volume control, how can understanding this entire pathway help us learn how to turn it down?